Okay, so now we're going to look at examples 2 and 3 on the alternative examples. Why don't you read number 2, press pause right now, read number 2, and when you're done, press play. Now that you've looked at number 2, a corner bet in roulette is where you place a chip down and it covers 4 of the 38 spaces. And so there's 4 different ways to win, which means that there's 34 ways to lose. So these are the two values and the probabilities. And it says, what's the player's average gain? This is a review of what we just did in question 1. This is the average gain kind of formula on how to do a weighted average, where the outcomes times the probabilities. And so in this case, we're just going to be multiplying the outcome times the probability plus this outcome times the probability, and that should give us what we need. You could just, when you write out the formula, this is how we show our work on this one, and then you show this, and then here is the expected gain. And a reminder that we can just do it on our calculators as well. I've stored them in list 1 and list 2. So if you look right now at list 1, that's the -1 and 8. That's the outcomes. List 2 is the probabilities. This one's the 34 over 38. That one's the 4 out of 38. And we can hit stat, calculate, one variable stats, list 1 outcomes. List 2 is the frequency or the probability of them happening. I hit calculate, and there's our average, -0.0526. Now, since these outcomes are in terms of dollars, then this number is dollars. So what does this mean? How do we interpret this? Well, this means that after playing many bets on roulette, the expected gain that a player has in playing on a corner bet is about -0.0526, or it's kind of like losing a nickel about every time you play the game, on average. All right, now let's look at example number 3. Why don't you take a second to look at example 3? It's the same as the NHL goals from example 1 with 0 up to 9 goals and the probabilities that go there. But this time, instead of finding the average, it says to compute and interpret the standard deviation. Now to find the standard deviation, we need the average. In fact, here's the formula for the standard deviation. It says the variance, which is the standard deviation squared, is the sum of the squared difference of the outcome from the average times the probability. Now remember what standard deviation is. Standard deviation is the typical distance from the average. That's why we're subtracting the outcomes from the averages. We square them to get rid of any negative differences, and we multiply it by the probability to weight it, because some of them are more often likely than others. But in the end, to get the standard deviation, we will need to square root the variance, or square root this part here, so that we can get the standard deviation. So what does all this look like? It's kind of hard with symbols, but what does that all look like? Here we go. So this is the part of the formula here that we had before. And instead of this saying variance, which is sigma squared, I just did the square root to both sides. And so it says standard deviation is the square root of all of this jibber jabber. So what does this mean? It means that the average that we got in number 1, the average expected number of goals, was 2.851 goals. So if we subtract 0 minus that squared times its probability plus 1 minus that squared times its probability and so on, then this is how we show our work for it, but I'll give you a hint. You don't actually need to type that big massive thing in your calculator because your calculator can just do it for you. Here's how that's done. For the goals scored, I've stored that for me in lists 3 and 4. So these are the number of goals, 0 through 9, and these are the probabilities of each, list 3 and list 4. So if I hit stat, calculate, and I do list 3, and then I do list 4 as my probabilities and hit calculate, then it'll do that big massive calculation, and we'll get the 1.63 goals, which is right here, and that's if you type this massive thing in, and that's how you get the standard deviation. Now, what does that mean? That means that after many games, a randomly selected team from a randomly selected game will be about 1.63 goals away from the average number of goals that we would expect to be about 2.851. So that means that typically what we would expect in NHL hockey is anywhere between 1 to 4 goals or so, which we can see kind of as the relationship between the average and the standard deviation.